Welcome, everyone, to Robot Builders Night Virtual, hosted by Dallas Personal Robotics Group, with members from the Dallas area and around the world joining us today, tomorrow, as the case may be, depending on the time zone. If you'll notice from the virtual webcam, we're not just a virtual Builders Night virtual, but we're in-person builder, as one of our members is holding his drill and actively drilling something. Thank you, Harold. All right. So with that, what we're going to do is go around the table and hear what people have been doing in the last week or so, and towards the middle or the end, chit-chat about the upcoming Saturday discussion, probably touch on the virtual line following contest. If Ron doesn't show, I think Will may have some updates, or I certainly have a couple updates. But anyhow, with that, I'm going to pause the microphone on this computer and show my face on the other computer. But meanwhile, hand over to you, Chris. The floor is yours.
Thank you. So yeah, that's just a quick thing from my end. So as I'm preparing for my thing on Saturday, where I'm going to go into more details on the simulation, I'm preparing the material, and I decided to do a simulated version of the Pololu 3Pi robot, right? Because I have one, and I got to make use of it. But then it dawned on me that, wait a minute, to do a simulated version of it, right, I kind of have to know how fast it goes when I tell it to go at 50 or whatnot, right? Of course, it doesn't have encoders, right? The Pololu 3Pi runs open loop, and they can do that because they regulate the motor voltage. So you just turn based on time, and it does a very good job at that. But if I want to create a model of it, I need to know how fast it goes at different settings. So I had to figure out how do I measure the speed, and so I ultimately came up with the solution. But I just wanted to poll you guys. I'm just curious. Again, in the absence of encoders, how would you guys sort of measure the speed? I'll tell you how I did it in the end. I guess sort of low tech, but then also high tech. I ended up doing slow motion video using my iPhone, right? And then I kind of single frame through the slow motion video, let it turn for 90 degrees, let's say. Okay, how many frames did it take to do a 90-degree turn? Okay, it's doing 240 frames per second, et cetera, et cetera. Do the math. Okay, and I actually got consistent numbers, so that seems to be a sane calculation. So I was pretty happy with myself at the end of it, because I just wanted to get to a number real quick, right? I didn't want to make a little sub project out of it. I just needed to know how fast do those motors turn, right? So that's how I did it. But if anybody has a better idea to do it in a matter of minutes, I mean, it did take me some fiddling around with the video. I didn't have a good way of, stepping through the video frame by frame. It was a little kludgy in iMovie on the phone. But, again, it worked out okay, to enough precision for my purposes. But if someone has a better idea, I'd like to really hear it, because that's all I could come up with.
Only other deal I would think of is if you could tape a toothpick or something to the wheel. So you got the wheel and you got a toothpick sticking out, and you get you one of these, because I've got tons of these limit switches around here for my 3D printers, right? And just has it go around and it clicks. And then I've got a Arduino sitting in there, and I'm measuring time between the clicks. And that gives me, I get a complete revolution every time the thing clicks, right? And then I could do a little math there, just like you did. And I had my initial thought, though, was exactly what you did, though. When you're asking for other thoughts, that's where I had to branch out.
Okay.
And I know you got an Arduino laying around somewhere.
Yeah, I didn't want to make a big thing out of it. I just wanted, I just wanted an answer quick.
Yeah, but I guess you got to build a little thing to hold the limit switch in place and that kind of stuff, and maybe that's a little bit much. But I mean, a couple of wires and a little bit of, hey, every time this thing clicks, record a timestamp, and spit that out in a stream.
Well, Chris, the way I would approach it would be to lay out a little course that has like a straight segment, 90-degree turn, straight segment, a 6-inch turn, straight segment, 6-inch turn, straight segment, 6-inch turn, straight segment, and then just time it as it did the loop. That's the way I would do it. But I have old tiles that we used to use for the line following. So for me, that's literally just 20 seconds to put that out and start running it, the timing lamps.
Yeah, I was thinking along those lines. The problem is in my room here, I have a dark hardwood floor, and I didn't have a quick and easy way of actually creating a track on the floor.
Yeah, well, I understand that. One thing you could do, like I say, I have the tiles, so it's just simple for me. But one thing you could do, and I have done this for demos, is if you just get a piece of poster board and a magic marker, and you can take it to the limit, try to just make a magic marker line, because the 3-pi is very good at following lines. I mean, if you don't have any switches or discontinuities, it'll follow it with no problem at all. So that's another, if you have a piece of poster board, that you can do it there, and you just measure the course and then let it run. You might want to do that to check your numbers. You've already got your numbers, so you don't need to do anything. But I'm just saying, is if you wanted to just check and see, well, does it really make sense?
Okay, good.
So I got a spin-off on Harold. So basically, like in the early line follower I did, I wanted to know the time delay, because I had to ship the video from the one base over Wi-Fi to the thing. So I wanted to measure the propagation delay through all the codecs. So I did a thing where I had the camera pointed at the screen on the computer, and the computer was showing what the camera was seeing. So then I would clap my hands in front of the camera, and then I made a recording of that, and I put it in the editing software, and it was really easy to just scrub through in the editing software and count frames.
And it occurs to me that if your robot actually had a speaker, what you could do is in your program actually make a little beep or something like that that would show up audibly at the same time. You wouldn't have to clap. You could actually have it in the program itself.
Yeah. So do you
in that regard, I don't know if I just zoned out, but do you have an IR sensor on the 3-pi?
Well, it has line sensors, down-facing line sensors, and that's about the only type of sensor it has, actually.
So if you have line sensors, can you make it so that you have an index mark on the floor, and then 3 feet ahead another index mark, and then just make it get up to speed, hit one index mark, mark the time in the software, hit the other index mark, and now it's self-timed.
Yeah, I mean, that's, somehow, running obviously it comes with line following samples, and I didn't have my own code yet at that time. So, but yeah, I guess the sample code would have been good enough to just run along a track. Yeah, it didn't occur to me.
I was gonna say you can measure back EMF. You've got analog inputs in the thing. That's easy.
Probably even cheaper than a piece of poster board is just take some copy paper. You could just make a file with a line down the middle of it, print it out about 6 or 8 times, and then just put them on your floor with a little tape. That way you could probably do it too. Because I mean that robot's only about this big, if I remember right.
Yeah.
And it can easily, I mean, like I say, it's a really good line follower. So.
Hey, Chris, which robot is it on the Pololu site?
The 3-pi, literally 3-pi, one word, 3-pi. It's been around for like, I don't know, a dozen years. They're still selling it, I think. I don't know how much, but it's a neat little thing. Again, it's a well-designed robot, like all of the Pololu stuff. I haven't used it much, and I've been wanting to use it, so that's why I trying to make use of it now, and with the simulator and all. So
yeah, it's $100.
Yeah, it is expensive, and what I do, I buy my stuff from Pololu only on Cyber Monday, which is coming up soon. So I'll be going shopping again in a month or two, because for $100 I wouldn't buy it. I probably got it for 60 or 70.
Yeah, I think I won this one in one of our contests. So it's
Yeah, for $100 you can get a Romy with motors with encoders.
yeah,
Yeah,
yeah.
That's the
Up a
only
little
reason I
higher.
have a Zumo
Yeah.
is that I like the Zumos, and I had an ongoing back and forth email discussion with one of their tech guys, and he even did 3D models of it and told me where I could cut the plastic away to put encoders on there. And I just kind of want to say, couldn't you guys just make a small change so you could put an encoder? You know, if you had encoders on the Zumo, it would be great.
Yeah, you could probably they sell encoders for those little motors.
Yep. Well, I've got them.
Yeah,
Yep.
so I mean, you know, if you wanted to, I'm sure you could put them on there.
Well, like I said, he'd gone to the trouble of actually, I mean, I don't know if he'd already had them prepared, but he actually went to the trouble, it seemed, to actually produce 3D models showing where each of the 3 different kinds of encoders they sell. They sell just the little PC board ones, and then they sell 2 that have connectors on them. And he showed where one of those would actually fit and where you'd actually have to cut the plastic, but you would actually have to get out the Dremel and cut the plastic to get it to fit.
Mm-hmm. And here, I think you'd probably have to cut the PC board because either that, one approach you might take is put a spacer to space it up so you wouldn't have to cut the board. But
then again, the 3Pi in theory doesn't need encoders, right? I mean, well, for line following, it doesn't because of the regulated motor voltage. If you want to do anything more sophisticated, it probably could benefit from encoders. But for what it's supposed to do, line following with the regulated motor voltage, I think it works. You know, feed-forward control is all you need.
You don't need. Yeah, I mean, I've run line followers for a long time without encoders. You know, you only need encoders when you're trying to do something that you want to be very specific. Like if you're running a camera, you might want to know the speed that you're going down the track and a few things like that. I mean, you could probably even, but you know, I don't think I had any, I don't think, in fact, of all the encoders, of all of the line followers I have, the only one I have that has encoders is the newest one, which I'm using that has a camera on it. You just don't need it for line following because the PIDs, you know, they could correct the direction. So if one's a little faster or a little slower, it's no big deal. You know, you just set them up.
So yeah, so that's all I had. So again, it's in preparation for Saturday because material I'll walk through is gonna use the 3Pi as a reference and the simulated version of it and a little bit of line following. And so again, I kind of needed to know how fast it actually goes so I can simulate it correctly.
Nice. Cool, thanks. All right, so who's next? Doug, do you usually like to start off early?
Well, I have admitted that I've been traveling almost the whole time since the last meeting, so I have done nothing. So that's a quick update.
That's cool.
So where'd you go?
I've done a lot of thinking, though, so I'll be busy next week.
Can I go next? For pleasure. Where did you travel?
I went to Utopia, Texas, where they had some tree houses, and we had our anniversary weekend. We had quite a fun time. A fantastic restaurant down there called the Laurel Tree. Won't help out people from New Zealand very much, but anybody around here, I really recommend it.
That looks cool. I'm gonna put you should put a link in there for it because Utopia, Texas looks very nice. Okay. Well, thank you. Okay, so John, I think you're chomping at the bit, as they say. What have you been up to?
It's quick update. I started writing a UI, a test UI, and want to implement some serial communication between my Arduino and the computer. So yeah, I did the component-wise testing that I can receive the serial communications. I'm gonna try to make it like click a button and drive a step or a shape to the motor and then collect my controller outputs. so yeah, I think I'm gonna carry through this. So hopefully show you guys some results. I get it.
So cool.
Yeah, thanks.
Cool. Yeah. All right. All right. Who's next? Who else has some fun stuff? Aren't we a quiet bunch tonight?
Yeah, it's a quiet bunch. I'll jump in. Okay. I'll share my screen at some point. I've been, as you know, kind of busy on the PID controller, and I kind of got to the point where I said I need to try something else. So I went ahead and I posted a blog entry and then put a link into the mailing list just I don't know, an hour or two ago. And so what I did is I made a beacon out of a piece of plastic I had lying around and a hub from a hard drive and 3 LEDs that are pink, of course. And that particular pink doesn't show up in my house much. So that was what I was testing, and to see if the robot's camera could see that thing. And so in high ambient light, it doesn't work so well, but actually inside the house, it works all right. And I'll show you, it's not fast. That's the only thing. It takes it turns out it takes about 600 milliseconds for the Pi's camera to make an image, even a small image. And so let's see if I can share my screen. It's always hard in this interface to find things. There it is. Present now. A window. So it'll be that. Share. Okay. So what I've done is I've taken the original idea that
The share hasn't happened yet.
it takes a while, I think.
Oh, there it is.
Good.
Coming right up.
What I had done a few months ago was I tried the camera pointing 3 meters away at a single LED aiming at the camera. And of course, this is now omnidirectional. And so what I've got now is a little program that I can run either single time or in a loop. This is running in a loop now. It's taking a 128 by 64 pixel image and on the front of the robot, and it's basically showing the position of, well, I'm trying to get it to work there. It's funny whenever you do a demo. I'll turn the light off.
Demo effect.
Demo effect, yeah. Okay, so what you're seeing is 3 different rows repeated. There's a sum, a peaks, and a peak, The sum is basically taking the summation of each column of images and then enumerating that and making a color. And then if I only have one of those peaks, it'll show up in the sum line as one peak. If the peaks happen to be within 5% of the image width, it'll then go ahead and create a single peak, I should say, and consider that that's the center of the beacon. And then that last line, the peak line, is where it's actually guessing the beacon to be. So if I move the robot back and forth on the stand, oops, did I just, oh, bloody. I have my robot, okay, that's the end of the demo. I just accidentally unplugged my robot.
Oh, no.
It just went off, okay. I should have ran it on batteries. I've got these power connectors. I've got the wrong power connector that has the little center a little bit too big for the actual post. So if I wiggle the robot enough, it'll actually reset. And that's just what it did right in the middle of the demo. But basically what you can do with this thing is about every 900 milliseconds, it can do a process by which you can find somewhere on that 128 pixel array where it thinks the actual beacon is. And it's somewhere around 800 or 900 milliseconds per image, which is not fast enough for line following, but I was trying it out in my lounge last night, and the robot can see that beacon across the entire floor and determine where in that image the beacon is. And so that's kind of where I'm at right now. And what I was thinking is that we had discussed, I think Dave Ackley had mentioned this as well, is that, or maybe it was Carl, I can't remember, or Doug, I can't remember who it was. Anyway, somebody was mentioning that the difference between the 2 PID controllers was, I think, an integral, and that was how you could do steering, or something like that. The idea being is if I have a number between 0 and 128, where 64 is the center of the image, and I say, oh, that's where we think the beacon is, I could use that as an input into a pair of PID controllers to say, how would you hone in on that beacon as you got nearer to it? And so that's kind of my next task, is to figure out how to do that. is how to take the difference from the center as a way to guide the robot towards the beacon. And this was kind of in line of how you would process this for that first pylon of the four, what's it called? The Four Corners Challenge.
Yeah.
So that was kind of what I was doing here, is how do you aim at that? How do you figure out how to aim at that first pylon? And so if this happens to be behind the pylon, then the robot could figure out how it would need to aim. So that's kind of successful, except for my demo, of course. But, you know, that's par for the course, right?
We'll spot you. I mean, for someone to stand up and show something, that's good progress.
Yeah, I'll put a link into the blog post because I just posted it earlier this morning.
Cool.
So that's
Why
what I've
does
been
it
doing.
take 600 milliseconds for the Pi to take a picture?
Well, it's
Yeah,
200 milliseconds to fire the camera up, roughly, and about 400 milliseconds to take a picture. And that's a 128 by 64 pixel image. If I bump the image size up, it takes longer. I'm not sure why that is. You would think it would be faster. I mean, obviously, you can do live video.
What are you using? Are you using that Raspberry Cam command line utility? Or, I mean, are you doing something? You must be firing up the camera for, you know, again and again for every individual picture. Are you not in some sort of streaming mode where you just take a frame and another frame? Because it'll do like 90 frames a second, you know, at lower resolutions. I mean, so I don't.
Well, that's what I was thinking. There must be something. It seemed somehow wrong. I'm not actually, as far as I know, firing up the camera every time. I'm doing a with statement, and with that, getting the camera and then configuring it. And I did an elapsed time count on there, and it's about 200 milliseconds to get the camera up and running. And then it was 400 milliseconds from the time I got the camera running until it took the picture. So, and that's just using a Python library to call the camera. But you're right. I mean, it does seem kind of bizarre.
There's got to be other libraries. I mean, again, I haven't done it in Python, so I can't, you know, but there's got to be other libraries that do a better job at that. I mean, just something doesn't sound right.
Yeah, I agree. I know when you think about it, it does seem kind of bizarre because it can do live video. So
yeah, but then again, are you getting a raw image, or are you getting a JPEG image that you then have to uncompress? Or
no, I'm getting a raw image. No, it's image capture, an RGB image. So I'm basically doing a with Pi camera as camera. I do a Pi RGB array, which is a library I'm using, and then it basically dumps the image into the array. And it, yeah, I don't know. I tried to figure out if it was my code, but my code's pretty fast. It doesn't, you know, it's just doing some image processing on a small array. So no, I think that's where most of the time is taking. So that's probably, thanks, Chris. That's where I'll probably try to see if I can optimize, is figure out how to get the image faster.
Yeah, different library is what you need.
Yeah, because if it is actually fast enough, you could use this for line following. Because right now I'm tuning it for that pink LED.
Oh, you definitely can. I mean, again, people, maybe what you need to look at is, and again, I haven't done this in Python per se, but within C and C++, you know, just, I'm pretty sure there's an integration of OpenCV, you know, with Python. And so, I mean, that stuff is set up for real-time video, right? So you want to just look at that and figure out what API makes sense for your scenario, because that stuff is meant for real-time video processing, and I've done it, again, not in Python, but you know, you can get a large number of frames per second if you especially at that low resolution that you're talking about. I mean, you got to be able to get 120 frames a second.
Yeah, well, at 128 by 64 pixel images, they're just, you know, they're really tiny, and that's all I need to get enough information to figure out where the beacon is. So, yeah, so I kind of consider this work in progress. So,
So one question: when you get the frame, then it saves it to the disk, then you load it in and then read it. Is that what you're doing?
What I do is I actually take the image as an array of pixels, and I shove it into what's called a Pi RGB array, which is actually a library. And that doesn't take very long. It just basically flashes the image array into an array of RGB values. And then I enumerate those values based on how close they are to the pink color. And then, so I'm effectively replacing the values in the array with their distance to pink. And then I'm collimating that into a single line array, and then everything from there is really fast, of course, if it's just milliseconds. So yeah, my processing doesn't take very long. So as Chris said, if I can figure out how to get a faster image off the camera, this should be fast enough for line following. And then the only thing you'd have to change in my code would be changing that distance to being something that returns a distance from, like a grayscale distance, like 0 to black or whatever.
The other thing I would encourage you to look at, and maybe you know this already, but anytime you want to look for a specific color, you want to operate in HSV color space.
Yeah. Yeah.
And
yeah.
I don't know if that are you in HSV or are you doing RGB?
No. I'm taking an RGB and converting it because I'm only interested in hue. I don't want to care how bright the room is. I'm looking for a pink hue. Yeah. So yes.
Cool. Well, that's some kind of progress.
Yeah, well, I'm pretty happy with it. I mean, I'm only looking to use it for this, finding a beacon or maybe an orange can, if it was in a bright room. But the idea of using it for line following, it kind of reminds me. I think it was. I'm not sure if it was Will or someone has that robot with that giant opening that it looks down with a linear array, and I kind of got inspired with the idea. It's like, well, I've got a camera. Why not use that? And so using a camera without going to this heavy-duty AI processing, just using a camera in the most rudimentary way was the idea.
Yeah. Very cool.
But I will now go back to the PID controller.
Exciting. We all have our pet projects to chase, don't we?
Yep.
You shouldn't call it the PID problem, because you don't know if that's the problem, right? Until you've gotten to the root cause of it. So you should find a new name for it.
Okay. Well, as we discussed in email, I'm kind of, before I try to debug it, I'm actually going to see if I can get Grafana or some kind of visualization solution so that I can actually just see what things are doing better. And that, I think it'll probably be pretty obvious when I can see the data, visualize what's actually going on. Either that or I'll just dig in and debug it. But I also just want to be able to visualize the data. So that's the Grafana solution is kind of something I can actually use at work as well. So it's something that I probably should learn how to do.
So how would you debug it though, right? I mean, because that's kind of one of the big challenges, right? I mean, on a robot, you can't just single step through your code.
No.
It just doesn't. That just doesn't work. So that's one of those big differences to any other kind of thing you're doing in software.
Well, I took the email that you'd sent about basically putting everything on a single line, and I actually had the PID controllers each generating lines of data. And what I did was I went up to the next level where I've got the class that actually has access to both PID controllers, and I'm actually on a single line creating what's effectively a CSV row of all the data from steps, the constants, the component values, live component values, velocity, intended velocity, everything on one line. And I'm basically writing that to a log file, which effectively is a CSV file. And the idea, once I've got the Grafana and Elasticsearch solution, is that as soon as the robot finishes its run, it will then basically take that CSV file and post it to a RESTful URL on the Elasticsearch server. In other words, basically either send in the data or replace the existing data, as long as you either create a new ID and create new data, or you can just overwrite the old data if you use the same ID. So effectively, end of run, dump the data to Elasticsearch, and now the Elasticsearch database is there for Grafana to just visualize all that data. And that's like a project in its own right to do all that. There's a Python library to write to Elasticsearch. Haven't got that running. And I've got Elasticsearch up and running. You create a data source in a Grafana and point it to Elasticsearch. And so in theory, I wouldn't call it trivial, but it's kind of a doable thing that's been done many, many times before. And then the only tricky part is using this Python library to point directly to Elasticsearch and send the data off. So it all seems kind of doable. And if I'll do a blog post once I get that running. But that's kind of a nice overall solution for any kind of data visualization. And so that's kind of where I'm heading on it. So I'll probably start on the weekend and see if I can tackle that.
Okay.
But thanks for you kind of guided me towards that by saying, you need to get the data off the robot, and the idea of turning it into CSV makes good sense. So,
yeah, it's just, I found that, I've been in situations where that still didn't help me, right? I was still banging my head against the wall, and that's why I would ask you, well, you said you're going to debug it, but how do you debug it, right? You can't debug a running robot unless it's a simulated robot, hint, hint, you know, or again, the other thing I've done in the past, which I found helpful, but again, it's a bit of legwork up front, is you feed that log data back into your code. Of course, your code has to be set up the right way. Again, it all involves work one way or the other. But I found that, it got me out of some jam, on occasion, being able to do that, because then you can single step through your code. But you're processing the same information step by step, and you can do that if you're logging every piece of relevant information, which, frankly, unless you're doing video, right, it's not that much. You have a handful of sensors. I mean, it's not all that much information if you think about it, right? So it's quite feasible to log everything and then sort of run your code I called it playback mode, and it lets you single step through it. And I'll talk about that some more on Saturday, but I mean, it all depends on your code being set up a certain way, right? It's true for simulation. It's true for this, playback mode. And, I mean, if your code's not set up that way, obviously it's a lot of work to kind of get there from here. But that's just, again, sometimes you got to do a little bit of infrastructure and legwork to solve the actual problem.
Hey, it's interesting. When I'm writing this communication, so what I did is I have the same C code running on the host before I have it. I mean, I did try running it on the Arduino just to make sure it's working, but I'm gonna actually write some code and simulate it first. By simulation, meaning I'm gonna have the code running on the PC side to make sure I can communicate from the UI to my response module before I put it running on the Arduino.
I mean, it's the way to go, in my opinion. Again, that's kind of an underlying philosophy that I apply all the time. I mean, just for a number of reasons, I feel it makes me more productive if I can run the code in Visual Studio on Windows, and again, just test portions of it that can be tested in just unit test fashion, right? Just standard kind of testing methodologies. But being able to do that,
step through the code. I mean,
exactly,
any new code should be stepped through.
if it's just code that's not sort of doing some sort of feedback control, right? The moment you get into a situation where you got state machines and all kinds of feedback loops going on, well, the ability to just step through your code on Windows, well, that's not going to get you very far because you don't have the stimulus coming in, right? But nonetheless, you can do a lot of upfront testing and get stupid bugs out of the way just by running your code, in Visual Studio first before you start chasing your robot.
I think for real-time testing, when I was working on DSP, I route some signal to analog outputs or digital outputs and use an oscilloscope, kind of trigger on some event and watch what's on the scope. Sometimes I log it, but that's a lot more trouble than just in the DSP route the signal to these analog outputs. Yes, I mean it's a quick way of like a print like a print, but it's on the embedded side.
Cool. So let's see. Swinging around, Mr. Will. At one point in there, you were holding something up. Did you want to talk about that thing you were holding up? Not Will's nodding. Oh, audio not working. I can see, can't hear. Your microphone is unmuted, but there's no audio coming across, Will. Somehow, maybe loose connection.
He probably has a switch to turn on to activate the mic.
Oh, the switch on the mic itself, maybe. Got to send an audio engineer his way. How about sign language? Okay. Sorry, Will. We're struggling with lip reading tonight, but if you can figure out the audio, we'll swing back around.
Carl, I
Yes,
wanted to show something that that might have relevance to Murray's.
Jump in.
Okay, this is something that there was a company in South Africa that made a robot that looked like this. Has anybody ever seen this? It's called the RBNV-I. So that's ROBONI-I. It's a very elaborate robot. It has, it was made for educational stuff, and so the educational competitions basically. So it has little targets that you can run over, and it's what do they call it? Like your tag that you have on your badge. You know, there's a sensor underneath, and you can literally pick it up. But where we were talking about here was that they have these infrared circular turrets that they use for a beacon. All right, so all this is an IR diode and an IR receiver in every principal point of the compass plus the midway points. So north, northeast, east, so on. Okay, and so it puts out a light. All right, now, but the thing that I wanted to say was that I thought this is really clever. This, let's see if I can get it where you guys can see it. This little turret on the top of this guy here has essentially 2 infrared LEDs here as receivers, okay? And one that's way back, and I don't know if you can see it, is there's a slot here. Can you guys see that slot? I don't know.
Yep.
Okay, and there's one mounted back in here. So what happens is if the beacon is over here, like this, hold on a second. It'll pick up on one of these side LEDs, but it'll only pick on this one that's a really deep trench, way set back in the trench, unless it's straight at it. Okay, so now, this is a way. This is a very clever way, I thought, for able to point your robot at a beacon. So otherwise, if you've got two on the side, one here and one here, which just generally tells you that your beacon's over to the side. All right, but when you swing in front of this long trench with the LED way back at the back of the trench, then you know you're straight onto it. I don't know if I'm making any sense, but
it makes a lot of sense.
Yeah,
I've used the exact same approach on my firefighting robot in the past to sort of hone in exactly where the candle is, right? Just some IR sensors in a tube, right?
Yeah.
And then, okay, the left one sees it, the right one doesn't, and then, so exactly like you're describing, fairly low tech, but quite effective.
Yeah, very cheap, I mean, those little diodes are what, 20 cents? Maybe I think you can get them for 12 cents. So anyway, I thought that might be something that you might consider instead of using a camera, because this is almost instantaneous. I mean, you can essentially, and there's no lenses involved except the lens that's on the LED.
Right, right.
Now,
Well,
so
the
you
way
have,
oh, go ahead.
when I say IR diode, I'm talking about a detector diode.
Yeah, yeah.
Okay. I mean, they come in sets usually, a detector and an emitter. So I'm just saying using the detector, and you just have 3 of them, and one of them's like Chris said, in a tube, and you only, when that center one shows up, your robot's pointed in the right direction.
Yeah, I had kind of my earlier experiment was just with an LED, a single LED aiming right at the robot, and it was a clear LED, so they're fairly directional. And if I continue to take that approach, then I think the camera, like I said, even in daylight, can see that pink LED even at 3 meters in daylight. But I kind of had changed my requirements, and now I'm using this omnidirectional thing so that the robot, when driving around in my lounge, could see it theoretically from any angle. And so it's a bit different. I mean, if you used either a pink LED or an infrared LED with an infrared sensor, and either or something to constrict the light, yeah, I agree that would certainly work. But I'm kind of trying to do it where this beacon could be sitting somewhere in my lounge, and the robot could come into my lounge and just kind of inadvertently see the beacon.
Yeah, but that's how it works. I should have pointed out. I just packed it all up. When I say they have 2 side ones in the front, they also have 2 side ones in the back. So anywhere that beacon is in the room, it knows which quadrant it's in. And then it will rotate. And it'll rotate until the tube in the middle is facing right at the beacon. Okay, so the motor...
Is the beacon omnidirectional? Is the beacon omnidirectional?
No, well, it goes in all directions, yes.
Okay, all right. Well, that would suit then, because that's what this is attempting to do.
This guy here essentially has eight transmitter IRs and 8. Well, I don't think it has 8. I think it has 4 receivers. No, it has 8. It actually has 8. I take that back. It has 6. Okay, so they've got 6. They have 6 emitters and 6 receivers, and they're all shooting all back off. Now, why they have receivers is because when you line, what happens with this robot is when it lines up so it's pointing directly at the beacon, a little row of LEDs lights up and it makes a noise, beep, and then this guy starts flashing. Okay, because it gets hit by an emitter. But that's no, you don't need that.
No.
But I'm just saying but the idea of having 4 receivers essentially looking for it in the quadrants, and then 1 in a tube. And like I say, they're very inexpensive, and they do have if you're in the IR, those diodes, you've used your remote, right? Your TV remote, you kind of get a feel for the range. So, you can pick it up from a fair distance. Anyway,
well, it does occur to me though that I've got this camera on the front of my robot, which I use for doing videos from the front of the robot. And it's kind of hard to swap out that camera, but I actually have one of the Pi infrared cameras. And if I turn this beacon into an infrared beacon and use the infrared camera on the Pi, it would actually work really well, because then all the other colors of light wouldn't be popping up, because there's a filter built into both the camera and the beacon itself. And that would work probably a lot better.
Well, Ray might have some insight into that. I don't know. I know he does usually takes the IR filter out of his cameras, but I don't think he always does that. You don't do it all the time.
You can get bandpass filters that pass infrared only, and then but if you do that, you're going to lose any visual, stuff in the visual band. There's a thing called a filter switch in a lot of the cameras. see if I have one here. Yeah, here's a couple examples of them. They are used a lot in security cameras because, and that one here on the end actually has an infrared filter in it. I don't know if you can see it. I'll hold it up. But, it looks kind of like a mirror in the visible spectrum.
You're not on. Yeah, there you go.
Yeah, so it looks like a mirror, but that actually passes infrared, so it would reflect any visible light that came through it. And you know, it actually flips back and forth between the two, between an infrared filter, and I stuck in an infrared bandpass filter, and so that way you can look at, you know, when it blocks the infrared, you get kind of the normal colors out of the camera, and when you're just looking at infrared, you only see the infrared portion.
Right.
But and there's two little wires on it, and you just pulse it for a little bit, and it'll actually flip back and forth between the two. So yeah, and it does improve it, like, you know, even in bright light, you know, you can see an infrared, like laser or infrared source. So,
Right, and they're not that expensive, are they? They're just a couple bucks, right?
yeah, they're cheap, and it was more difficult to find the right form factor. A lot of them are square. That particular filter switch required round ones, so I had to search around to find round ones. But it's a website, aixiz.com.
Can you put it in the chat?
What's that?
Put it in the chat.
Oh, okay. They sell a bunch of that stuff, and it's cheap, or you can just look on eBay for it. But can I grab the thing? Yeah, because I wanted to show you something on the. This is doing. If I can do it. Details. Come on. There we go. Okay, screen. And let's see. Sharing. Okay. Everyone. Oops. Gotta get rid of that. Do this. Okay. Can you see that?
Mm-hmm.
Okay. So this is doing just single color, you know, RGB 565 blob detection, and it's down here. It's doing about 19 frames per second on a quarter VGA image. So I know it sounds like you were doing histograms. You were like tallying up pixel counts in columns. Is that right? Yeah. Yeah. Anything you do with individual pixels seems to take forever in any of the video processing things. And they kind of recommend not, doing pixel diddling and stuff like that. But that tracks it really well at that frame rate. I don't know if you can see the image. Can you guys see that?
Mm-hmm.
Yeah.
So is this on the Raspberry Pi, or what's this on?
This is on the OpenMV H7.
All right. So this is the OpenMV IDE, right? Okay, got it.
That's right. Yeah. And it's similar. A lot of the things are similar to OpenCV, but he's just got hundreds of examples of things, and it's not like the Chinese stuff where it may work, or in a lot of cases it doesn't work. It just
what stands out to me from what I see there, that you can turn auto gain and auto white balance off, because I've always found that to be a real problem. And maybe nowadays it can be done on the Pi with the Pi cameras, but that stuff gets in the way of color tracking, and it's interesting to see that you can turn it off here.
Yeah, because if you know, if your lighting changes on a color selection,
Yeah.
you're changing the colors of it, so yeah, so it could lose it. So yeah, if you turn it off, it's well, here he's saying must be turned off for color tracking. Yeah, so but I actually tried lower resolutions. It doesn't seem to get any faster, which I was surprised. It gets a little bit faster, but not much. But yeah, anytime you're looking at individual pixels, like get pixel, set pixel in OpenCV, it for some reason takes forever. I guess it's just not set up to do things like that. But a lot of the filters that are used can be incredibly fast, and they're running like a small matrix over the whole image, a 5x5, a 7x7, and it seems to be able to do that without any difficulty. You're multiplying the values of those, of that 5x5 pixel group with whatever your mask is or your array is, and then computing the value of one pixel, typically the center one, and it does that over the whole image line by line. And, it seems maybe it's optimized to do those things or something, but
So is it faster than the Pi with OpenCV, or is it just easier to use in the end?
With the OpenMV H7, a lot of the things are going to be faster than on a Raspberry Pi, but he's continually optimizing his examples and stuff, and he'll publish little notifications that they've been working on whatever routines to improve them, and in some cases he makes some pretty dramatic improvements on his examples and stuff. So yeah, with smaller images, especially with the OpenMV H7, and especially with the global shutter camera, you can get up to like 240 frames per second without any issue with small images. It's super fast. This one is not a global shutter. The camera is not, and it's considerably slower. So, but yeah, so I just wanted to show that you could get, you could track things with fairly high resolution, quarter VGA kind of image, and do it, at a decent frame rate, so that you could still, use it for line following or something like that. Typically,
right.
Yeah.
It's usually faster too if you're not using the IDE, right?
Yeah. Typically, 2 times faster. So.
So you say 19, but it's probably more like 30.
Yeah, maybe 36 or something.
Mm-hmm.
Above 30, which is most of my loops. I only run 20. So if it's doing at least that, a little above that, then it doesn't, influence the motion of the robot very much, because you're updating it as often as you update your motors. So anyway, just wanted to show that.
Cool, thanks.
Sure.
All right, I want to jump in and do a very quick thing. It's very quick because I didn't have that much time this week. Beyond the other stuff, are you able to see my screen now? Is it showing?
Yep.
It is showing. Okay, so you might recognize Ron Grant's simulation environment, which I took his latest version and got it set up on this box. And you'll see that unlike the Will robot or the Ron robot, this one is kind of elliptical and it's got 4 wheels. Woohoo! So I was able to make it show 4 wheels like a Mecanum.
Yeah.
And I figured out the coordinate system and the scaling. So he has basically it's like 64 DPI. So whenever you specify these sensors, and I just did these kind of semi-randomly so that I could know the dimensions and orientation. I just did them to kind of understand the scale and orientation, and like X is front to back and Y is left to right, kind of like the economist's view of rise over run. But then this sensor model, it's a really cheesy model of Flow, who has an integrated 8 element line sensor. So I thought that I'd model it, and anyhow, I have a different sensor concept for the real deal, 2 of them actually, but those are secret. And once I get them to work and run, then maybe I'll reveal it. Or you could just snoop in my repo because it's public, but you have to know how to use a repo.
Hey, Carl?
Yes, sir.
So is this out on the website now? I mean, excuse me, in the GitHub?
Well, mine is not.
No.
Ron's, yes. So this is where you go, and I'll put that into the chat window here.
Okay.
And I can give a suggestion. I think Ron was going to present something on Saturday. I haven't talked to him in the last couple of days, but I can give a kind of tutorial as well on a kind of a Git way to set up and run this. So, for example, you'll see if you look in the Git history on this that Ron did the initial commit. It goes from the bottom to the top in Git history, and each one of these steps in time is another change in some set of files. So like this one, if I click on that, it shows you that he added, like compared to the prior version, he added these, where'd it go? These 9 lines. So that's the difference of what he saved.
Yeah.
Right. So it's really handy. And in some of these, you'll see multiple files change. So you can see this one had 3 additions and a bunch of deletions.
Yeah.
So anyhow, it's really a handy tool that way and tracking the history. But at some point here, you can see that what happened is that I took this point in time, and then I started a new robot controller to explore Mecanum wheels. And then I made the basic shell and reference outline. So I'm doing my work in my own fork of his repo called MechSim. But shortly after that, I came in and I proposed a change to his README file. It was a real simple change. And then I proposed it to him with a pull request in Git, and he merged it into the master. And then I came back later and merged into my master. So anyhow, we can both be working in parallel on similar sets of code, and all it takes is a little bit of Git wizardry, and so now I can comfortably advance my Mecanum wheel even as Ron is working on the simulation environment, and then I can decide if and when to pull down the changes he makes into my local version of it. So I think hopefully we're going to keep going in that way. Ron is learning Git as many of us are, but let's see. Hopefully this will be a nice stable repo we can build on.
So were you actually able to get the simulator to simulate Mecanum wheels, or?
I haven't done it yet, but I will. I mean, all I did so far, like I said, was I figured out enough to get my local build environment running, and I've been doing it with I've been doing the code manipulations here in Visual Studio Code, and this IDE is pretty nice. As soon as I make a change in VS Code, you just hit launch and it takes it right away. So so I can use a proper editor instead of these dorky things.
Wow.
But yeah, so I'm very close to the next step for me now that I got the basic infrastructure there. The next step for me is to decide which of the two sensor concepts I want to go with. One is based on those Pololu things, and the idea was if I did it that way, then I could get the simulator running with something that could be easily physically realizable. And that's one concept. The other concept is to bug Ray, pick his brain on the OpenMV H7, and instead of relying on a whole bunch of soldering to take a whole bunch of sensors, just use one camera.
Oh yeah.
So
you have one already?
No.
Oh.
Well, I mean, you know me. I'm going to start with the simulator before I buy anything.
Oh, okay.
Except for stuff that's fun. Then I'll buy it and sit on the shelf. Which Harold is well aware of, because he and I have been having the same problem. But yeah, so we'll see. At some point, I'm going to verify the API run-in to move the robot sideways, not just front to back or turn. So hopefully by next week, I'll have a little bit of motion to show. But
so you just tell it to move sideways, and it moves sideways. So I mean, I'm assuming there's no underlying physics going on here with mechanism wheels, but that gets really complicated, right?
Yeah, I wouldn't say he's got. I mean, it's not a high fidelity model, right? And he doesn't have momentum model down, so they give it a mass, right? Give it forces, and it does the friction. It does. No, instead he's got like lags and response time kind of things that kind of behave like momentum or other things, but they're not real world.
Yeah, but because even for the simulator that I'll talk about that involves a real physics engine and all that, you know, doing something like mechanism wheels is you kind of at the limit of what the technology is capable of, and I think that you end up having to do some cheating there too. I'll have to read up on it because I'm not sure how it's done, or if it's done based on physics or just kind of, you know, cheating in a way, because that gets real hard. Mechanism wheels are hard.
I'm on a semi quest ever since I bought these and started playing with the mechanism wheels. And the funny thing is that the way I have the code running in my physical one, and how I will run it, the way Ron has this simulator set up, is that there's basically 3 velocity loops. Okay, you give it a lateral translation, either forward or sideways, and you give it the command in velocity units. So you just say, I want to move forward so many watts per watt, or sideways so many watts per watt. Or for rotating, it's the same thing. I want to turn to certain velocity, so many radians or whatever per watt. So, and then for the mechanism movement, the math is remarkably straightforward. I forget exactly. I have to look it up, but basically you take. There's a way that, like for this motor, it's like forward plus sideways minus turn, and for this one, it's forward minus sideways plus turn. So there's several combinations of the 3 units, and by how you take those velocity commands, translate front, sideways, or turn, and you map those in 4 really simple equations to each wheel, then it just somehow magically works.
Yeah.
And the part that I need to calibrate now is, you'll notice that it's probably like more of a rectangle than a square, and I have this sneaking suspicion that it has to do with forces on how it goes diagonal, and I have the sneaking suspicion that if it's symmetrical, then it's pretty nice. But if it's like more of a rectangle, then the forces don't work out evenly. So I was going to measure that actually in the real world with my real world one, because it's longer than it is wide. And I was just going to calibrate, okay, I go at so many ticks per second this way, front to back, so many ticks per second left to right. So if I go diagonal, so many ticks per second, is it linear on distance, right? So what's the scale factor when you go off of direct axes? And is it the same front to back as left to right? So that's on my my quest to answer at some point.
Carl, do you think there's going to be an ambiguity? Like you can, I guess you have two choices. You can move left to right as it's moving forward, or you can turn, or could you accomplish everything with just moving? Well, no, you can't, because you're going to come up to a perpendicular line. So at some point you have to turn, choose a turn.
I don't think, well, for these curves, you'd have to be able to, yeah. So in theory, you could argue that if you wanted to get a little crazy, you wouldn't have to you could keep it the exact same orientation if you're really clever, right?
Yeah.
But I don't intend to be that clever.
Okay.
No, I'm going to do some cool things that you wouldn't normally see on like a diff drive robot. I'm going to do some cool things, but I'm a few steps. I got to get those cool things, those simple cool things before I say, okay, it's going to traverse this course, but hold the same orientation the whole way.
Ooh, yeah.
Yeah, that would be like lead table, but I'm not going to do that for a while.
Yeah.
Here's David Anderson waving his fingers around. What are you saying, David? You're muted, David. Unmute. Oh, you can't get the audio to work. I'm sorry.
How about now?
Oh, yeah.
I was saying, instead of maintaining the same orientation everywhere you go, I want you to maintain a constant pirouette.
Well, that's
wow. Yeah.
That's exactly in my. That's the first list. Okay, so David, except for the fact that this virtual contest is going to detour me for a little bit, that's exactly why I've been paying attention to all the discussion on the BNO 55 and the other IMUs, because I very much like all of the times we do the out and back contest, right? Go forward 12 feet and come back 12 feet. I want to be able to do it with my Mecanum wheel where it's spinning the whole way. And then it spins and comes back. So straight line spinning and then straight line back.
Have you seen RCAT robot do that?
No, you haven't?
I brought it to an RBO one time and demonstrated it. Yeah, and it can follow any arbitrary way path. So the one I ran at the RBNO, it just did a great big triangle, I think, while spinning. And it accelerates and decelerates when it comes to the...
Oh, man.
So the gauntlet is thrown down.
As usual, we're humbled.
You're such a show off.
Especially because that thing has 6 wheels, right? I mean, it's just a drag turn.
No, it's the RCAT, the little 3-wheel indoor robot.
Oh, the 3-wheel, okay.
Yeah, isn't that effectively those robots that are round with 3 mechanics on them that are balanced on the ball or whatever else? Anywhere they're moving, they're doing what your spinning robot would be doing, right? The same kind of mechanism. None of them go straight ever. You know, that kind of thing, right? So,
right, they're always.
I was fascinated by watching ice dancers and how they seem to be able to arbitrarily change whether they're going forward or backward in the course of making a transition. And I thought it would be cool if you could have a robot that could do the same sort of thing. So I sat down and worked out the math to what was required to do a pirouette in a particular direction. You know, it's just, sine cosine,
It's just math.
Maybe work on getting going in straight line first and then that later.
Let pass them by. Let me see if the robot starts up, and maybe I can get it to demo before we're done.
Oh, cool. Yeah, that'd be neat. Okay, cool. So let's spin around while you do that. And Mr. Jack, how are you this evening? Past the presidential debates, I hope. No? Oh, he's muted. Your audio's not working, Jack.
Oh yeah, that was on tonight. The vice president's, right?
Or tomorrow night, I think.
It's tomorrow.
But last meeting, Jack was watching it, and we could hear.
The only question is, will they have class between them? Is the thing. So
I was watching the last one too.
Okay, Jack. You're working on your microphone. Let's check
all of them. So
what?
they turn into, hey, Is the sky blue? Well, I was wondering if the sky was blue or not, but really we need to be concentrating on this thing. It has nothing to do with the sky. It's a yes or no answer, and they turn it into a big dry fire about whatever they want to talk about anyway, and they don't answer the question, and so I'm just done with them all. I don't care what side of whatever fence you're on. I'm done.
There you go.
Yeah.
Is my already working now?
Yeah, Will, we got your audio. Okay, so what were you showing a little while ago?
I'm starting a new robot, and this is the front wheel that I'm building for it. It's as usual, it's plastic and it's plywood, has a molded rubber tire on it, and used aluminum ring for the encoder. I'm hoping to be able to get about 16 counts per inch on my robot.
Oh.
So it's an optical encoder?
Yes, it'll be the standard interrupt encoder. In fact, I plan to put 2 of them on there so I can get quadrature.
Oh, yeah.
Yeah.
So 16 ticks per revolution.
16 per inch.
Oh, per inch
travel.
Oh, wow.
Yeah.
Will, can you hold
So
it? Can you hold it
that's
up
basic.
to the camera close so we can go kind of?
I don't
can't seem to get it. Never mind. Maybe.
There you go.
Okay, now I can see.
Can you
it.
see it now?
Oh, yeah.
Yeah,
Yep. So did you
Yeah.
buy that or make it?
I'm sure
I
you
made it.
Yeah.
No.
So did you make it by essentially slotting a tube, part of a tube? Is that how you made it? Or are those
Actually,
little
I rolled a strip of aluminum and rolled it into a ring, and then epoxied it in the wheel, and then I cut the slots for the encoder.
Okay, cool.
That's
Nice.
hard.
How'd you cut?
All right, that's all I have, I guess.
So you're going to go for the 1-to-1 gear ratio.
Yeah, I may use this for my motor.
All right.
Huh.
Cool.
Is that a stepper?
No, it's just a DC motor with a gear train. It this output gear runs about 45 revolutions a minute.
So how did you index the cuts on the aluminum?
I have a little rotary table that I use for that. So
Okay.
there's a slot every 8 degrees, I think.
Okay. Yeah. I was gonna say you got to be pretty precise with the slits, because otherwise it's gonna go faster and slower if they're not.
I think they're probably uniform within a couple thousands, maybe not.
Wow.
So, Will, do you have a mill? Is that what you're using them with, or on your table?
I have a real little Harbor Freight mill and a little 3-inch rotary table.
Gotcha.
Okay.
Whoops.
Yeah, and I inherited a pretty good sized rotary table that I can barely lift. So.
Yeah, that's been on my want list for a long time, but I don't. My mill, I just have one of those Shoreline mills, and so everything I can try to get is kind of a little too big. So the 3-inch one would probably be about what I would need.
I bought this from Grizzly.
Okay. Yeah. Is it a phase 3 or one of their clones?
Yeah, I don't know what it. I just know they sell it. Actually, I bought the 3-jaw and the 4-jaw chucks also.
Okay. Wow. Okay. Cool. Very cool.
One that I inherited.
All right.
I think it's got like about a foot diameter platter on it, and it probably weighs close to 100 pounds. So that's why I can barely lift it.
Yeah, but you got a Bridgeport, don't you? You
Yeah.
have a Bridgeport.
Yeah.
Right? So, I mean, we're talking about, dinky, 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 dinky compared to yours.
Yeah. This thing's a monster.
Yeah.
Cool. All right. Hey, Mr. Jack, any luck with your audio?
Is it working now?
Yeah, we got you.
Oh, okay.
What you up to?
Well, not much. Just a bunch of school this last week. Hopefully, I should have some free time this weekend to work on it some more. But,
All right. Yeah, well, it's a higher calling. That'll be good for you.
Okay.
That's
Excellent.
cool. It gets in the way sometimes.
Let's see. Mr. Harold, you got your Twitch channel in the chat there for those of us that need to be catching up on the Twitch world.
Yeah, come twerk with me or twitchy with me or whatever, some of those things. I'll show you what I've been working on here. Getting closer to the robot, and I built one of these things. I modeled it up.
Ooh.
I modeled it up, and I came way closer than I thought I was going to do. I measured twice and modeled once or something. Actually, I modeled a couple times and printed up make sure I was on the right way before I went too crazy with it. And when that all got printed out, here, let me go overhead and close up. And all I got printed out, it turned into this, and which is what I was drilling on a little while ago. So what happens now is I got some Velcro. Here, I'll get my little close up here so you can see some of that stuff too. I got the Velcro on there, and I've got it bolted down in all those holes that came off of these TurtleBot models. The TurtleBot 3 plates that you can print out on your own printer. And I just lined up with some holes. And some of this looks like I bought it this way, and I'm like, hey, that's kind of cool. And then I got it so I can get to things and do stuff and route things, and it flips down. And I just did get this thing put on as we were talking. That's what I was drilling out the holes of to see the and so I was the last couple times I've been twitching up this model and cussing up a storm because showing me exactly how much I do not know about Fusion 360. Which, by the way, I got a little bit of bone to pick, but it's all right. They just changed some terms and stuff, and I know the folks have to make money, and I want them to keep making money because I actually like their tool. I mean, it's essentially a pro-level tool, and so not that I'm going to become a 3D modeler extraordinaire, but the skills that I learned with these top pro-level tools are not are translatable to other things, as opposed to learning. Like Tinkercad's not bad, SketchUp it's not bad, but those aren't pro-level tools, so you're going to have to learn some more and go do, that kind of thing. And so I'm trying to, I don't say be efficient, but, if I'm going to learn something, maybe I'll be really good at it. So let's use something way better than me, so I'm not fighting the tool. I'm fighting it because I don't know versus I'm fighting it because I'm above its skill level to allow me to do things I want to do. Does that make sense? Maybe it does.
Yeah.
And so what needs to happen now with the little Mr. Robot, because last time I talked to you, I was whining about I couldn't talk to Fermata worth a damn, and then I can talk to Fermata worth a damn. I got the Arduino. I got the system on a chip here, the Latte Panda, here talking to the Fermata to tell it to drive the wheels using servo controls, up, down, left, and right, that kind of stuff. So it'll drive forward. I mean, the wheels will go forward, it'll go back, and now it's time to do the coding. I will probably be a UWP program, and I end up doing it just because it's the way it's portable. Trying to get the gamepad in here and actually make it send those same signals to the Arduino, but with the joysticks on it, left, right, up, and down. And then once I have it running around the ground, hopefully I'll have pictures of that here in the next little bit, or videos. And then we'll see what else I go. From that point, I can control it. I've got stuff on here. And maybe then I fire up some of the raw stuff and get it controlling it itself, like having it go forward 10 feet and turn around and come back, that sorts of things, and have that kind of make that stuff happen. And then I'll figure out what to do next on it. It doesn't have any sensors. I mean, it's got encoders on it, but it doesn't really have any sensors. And so I'll need to put some kind of camera thingy-bob on there, or some kind of other kind of sensor on here for doing stuff, or at least bouncing into things. And I think that's kind of where I'm going next. I will tell you though, I did run across a person, and I don't have their link handy, but I'll find it here in a minute once I get done talking. There's not a whole lot of people doing robotics, and there's not a whole lot of people doing what I'm doing on Twitch. Most of them are either software developers and game developers, if they're doing anything other than gaming. And so I'm over there. I'm up there trying to preach it out a little bit, and hopefully the idea is you want to build a community. You want a community that does a thing. How about you go do that community, and hopefully somebody will come along and play in your sandbox with you. And that's kind of where I'm going with that. I'm up to about 44 followers, so that means every time I hit the go button, 44 people get annoyed. So that sort of thing, and so I am learning some more stuff as I go and do, and I hopefully will get more people going along these lines as I either become. I don't know if I'm that entertaining. But I don't know if that I'm bad, because I've seen some really unentertaining people. Like Mr. Urologist, he's not all that entertaining, but he has thousands of followers, and they got other people that are very entertaining, and they're making donuts like the Donut King, but he's really entertaining, so people come watch him. And so this one link I was just talking about, some fella has got one of the little robots. It's on a charger, and all this Twitch stream does, there'll be 20 people watching it for no good reason. I found him. I go in there, and you can issue chat commands like you tell it to go off the charger, and the little robot will roll off the charger, and you can see he's just live streaming his robot on a platform, and you can put in commands to have it spin around and go left and right and turn and those kind of things. I'll find the link and I'll put it in the chat when I get done talking. But it's actually a nothing thing, but he's got thousands of followers and 20 or 30 people watching him anytime I get on, day or night, and doing this stuff. I'm like, if that's all it.
Uh-oh. Battery failure. Harold, he's back again.
Yeah, Google has decided to start throwing access violations on this lab PC that I'm on. I have no idea why. Maybe I need to upgrade something, or maybe I'm asking it to do too much. I don't really know. But there's got thousands of people watching this little, you can go control the stupid robot. And I'm like, I can at least be that entertaining. And then hopefully share some knowledge at the same time.
It's awesome.
Yeah, just trying. Whether it goes anywhere or not, I don't know. I'm still going to be in here doing that, regardless whether anybody watches or not.
Yeah.
I mean, I care that I want to share. I want to be more interactive with folks. But if they don't decide to come, I'm still going to be doing it.
That's cool.
It's working. Maybe. Do I have audio?
We got your audio. Are you ready to demo?
I believe I am, if I can get the camera to point at it.
All right.
Awesome.
Huh?
Yep.
Yep. All right. I think if I have enough room here, I just told it to go just 5 feet forward and 5 feet back. And maybe I should run it diagonally so we have a little more space.
All right.
Still see that?
Yep, we can see it.
All right.
Magic buttons.
Wow.
Oh, I'm getting dizzy. I'm gonna puke. That's amazing.
And when it gets there, it'll zero in on the waypoint, and then it'll beep, and it should start back.
Oh, that's robot bragging right there, I'll tell you.
Now, how fast can you translate diagonally like that, or what did you call it?
Pirouetting.
Yeah.
Pirouette it. Pirouette rate set, but I can make it pirouette much faster, and I can actually make it drive faster. So those are all independent. Was that your question?
Yes.
That reminds me of a YouTube video I recently saw. Someone has, for the 3Pi, created exactly that. It's doing line following while spinning at mind-boggling speed. I mean, it's just becomes a blur, the way at which it's spinning, and it's following the line. Now, it's not following the line very fast, right? So, but it's I don't know. I don't know how it's done. It's quite amazing.
Well, I had actually practiced quite a number of years to learn how to do that with my helicopters. It's what the helicopter pilots call stirring the sticks. In fact, I can show you.
Yeah, that's a different thing entirely to do it by hand. I mean,
It's kind of what got me started. Can y'all see that?
oh yeah.
Okay. For a helicopter, this is your collective. So think about that as the pitch going up and down. And this is the tail rotor. So that's what makes you go around the center. And this one here basically leans the head back and forth. So basically what you do is you go up in the air and you push forward on this and you start going forward. And now I'll move the tail over so you start spinning. But that would just spin in a circle. In order to keep going the same direction, you have to do what they call stirring the sticks, which means you watch the helicopter, and as it goes around, you have to do this in the opposite direction. And you have to do it exactly in phase with the helicopter. And if you do that, you can fly it anywhere you want. You know, you can fly it arbitrarily. And I spent years learning how to do that because nobody else in my club could do it. And then once I did it, I went like one Saturday and showed it off, and the next Saturday they could all do it. Totally humiliating.
Is this sort of like the monkeys picking up rice on the beach?
Yeah, but all you need is the idea.
Yeah, I remember back in the day when I was in RC cars, I mean, 30 years, 40 years ago, RC planes. And we went to some show up here in Dallas, and then went to that big airfield out there in Terrell, or Wills Point. Sorry, Wills Point. And we watched this guy, and he was famous for doing a couple of stunts, and one of them was called a rolling circle. So he got this plane and put it in a barrel roll and did a whole 360 degrees around the field and doing rolls the entire time. Same kind of concept that David was just talking about.
Exactly the same.
You're bumping. You got it in a roll, and you're bumping the elevator right at the right time to make the thing go around. To pull it around. Yeah.
But that'll just drive you nuts, though, because when it's upside down and coming towards you, you know, the stick moves which way, but the plane moves what way. And
well, he had one of those high performance planes in there that didn't matter whether it was flying right side up or right side down, so he didn't really care. So just as long as he hit it the right way, you know.
But that's just it, right? Because you got to have your perspective from the view of the cockpit, which is constantly moving.
Ooh. Yeah, I couldn't do it. I'd be the guy that was, picking out parts out of the wreckage. Wheels.
One other thing I thought I could show that might be helpful. Just a little quick demo, which I'm going to try to do by just balancing the robot on my knee. Can I do that? Can you see the robot?
Oh, yeah.
Just barely. Okay. What I want to do here, I know both Harold and Murray were working on low-level things like speed and velocity and PID control and so forth. And I wanted to offer a real simple way to check if your PID controller is actually working. Right now, what I've got on this robot, I just turned the PID controller off. So I'm just running open loop. And he says, hang on. And I've hooked up that open loop. I've got a knob here, a generic knob that I can connect to any arbitrary parameter. And so I've got it hooked up to that wheel. So can you, you can't see it at all.
There you
can
go.
You
now,
pick direction? Okay, well, what I want to do here, be sure I know what I'm doing. Every move is carefully planned.
Demo effect.
Yeah. Also, remember what these buttons do affect. All right. Can you see the wheel?
Yeah.
All right. What I'm going to do is I'm going to run it real slowly. Right now, I'm running it at about 20% power. And so that's without a PID controller, I think. And what you can see is if you add friction to it, it slows down. And if I add enough friction, it comes to a stop.
Yeah.
All right? That's without PID controller. The equivalent of that, if I put it on the ground, well, I'll show that in a minute. All right. Okay, hang on.
A little byte code to load there.
All right, this is now the same thing with the, I think. Let me set the speed down. This is the same thing with the PID controller turned on. Or so I think. Oh, sorry. I've got a lot of sensors turned on there messing with me. This may be more trouble than it's worth. Okay, so there's the same thing, but the PID controller's in the loop now. It's not just open loop. So if I grab it and start to put pressure on it, see it starts pulling real hard against it. And the harder I press, the harder it pulls. It doesn't slow down at all. I cannot bring it to a stop. So if you can do that, your PID controller is working. Without any charts or graphs or anything. And if you won't do that, your PID controller is not working. I can.
Well, David, I'm proud to say that actually my PID controller does that.
All right. All right. You try. Can you see that on the floor there? If I turn the speed down really low, that's when it's most obvious. So now, can you see it? So if I grab it starts to really tug on me, and when I let go, it quickly slows back down. That's all.
PID loops, solving today's challenges.
Well, I was kind of, just to answer David, I actually had prepared a little YouTube video, which I kind of almost had got ready to, I was thinking about even posting it and showing it tonight, but I decided that I sounded way too much like a radio disc jockey and I'm going to do it over again. But basically, I can tug on that back wheel on my robot and it actually does, you know, it really pulls. Yeah. And so I figured that was probably working okay then.
So PID loops, what?
When you let go of it, it should slow down really quickly.
It does.
It ramps the voltage up, and it can't take a long time to ramp it back down. It needs to ramp back down quickly in order to respond.
Yeah, it's within I don't know, a third of a second. I don't know. I didn't time it, but it, yeah, something like that.
So PID loops are like what, 1950 technology that we're still doing what it's supposed to be doing, or something along those lines?
Well,
every
hell,
upgraded one.
wheels. We're still using wheels, aren't we?
Yeah.
I think
it's awesome. I think it's awesome.
they're actually from the 1800s.
The other thing I would just add is that, when you tune a resonant circuit, the guys who describe these things in detail talk about you can being overdamped or underdamped or critically damped. And for our purposes, you can think of underdamped means that it never stops oscillating. And overdamped means that it never will oscillate, but it won't get all the way to the set point either. And critically damped normally means that you overshoot once and settle back in. Mm-hmm. However, having said all that, my experience is that a lot of the tuning of those kind of parameters on a robot are aesthetic as much as anything else. Mm-hmm. That is, do you want your robot to be really sharp, angular, maybe even with a little bit of a jiggle when it stops? Do you want it to be smooth, or to decelerate, and so forth? And there's no right answer to that. It's really a matter of taste and how you want your robot to behave. It's also a matter of, how much torque can your motors deliver, how quickly, and there's a lot of things in the loop there. So anyway, that's why I add that there's not really a right way to do it. And Kareem a couple of weeks ago said that he was embarrassed to show his PID controller because he just got it working well enough and moved off. And my very first thought is, we're all embarrassed to show our PID controller. We all feel like it.
Well, the point you were making, I mean, one of the things I've kind of been researching is, of course, Rodney Brooks from MIT and, the whole idea of behavior-based robots. But the second meaning of behavior, which is what I'm kind of interested in, is sort of what David's talking about. Like, how does your robot behave? Like, does it seem jerky and kind of mean-spirited, or does it kind of have a bit of grace to it? And, watching his go across this floor in pirouettes, that's kind of like a ballet dancer. He's got this ballet dancing robot, which is pretty cool.
Thank you.
You're welcome. And to answer Harold, David had recommended I get the first edition of this book, which is Mobile Robots by Jones and Flynn, because I guess the second edition got botched. So I actually found this online and bought it for like 15 or 20 bucks. It's 1993, which is kind of before Harold was born, I think, actually. But anyway, this book is ancient technology. It's like, you have the second edition, Doug. Wow. But yeah, the stuff's kind of old school in the sense that it's, TTL circuits and actual transistors and things, but the ideas in it aren't out of date. And that's kind of what I think David's point is that being able to have a PID controller tuned properly on a robot gives you the ability to provide these behaviors. And so that's not out of date.
I'll say also that you get that working, it's the first time your robot looks intelligent because it's responding to its environment. Hits a slope and it ramps up the power to climb up that slope. It looks like it knows the slope is there. And that's like the first lowest level of intelligence to respond to the environment. It looks intelligent.
Yeah, yep. I was going to say, if you get really sharp, jerky, quick maneuvers, not unless you've got a battery that can supply, large spikes of current, you're probably going to be, risking, other behaviors that you don't want. You're going to glitch your power rail and your processor, and, it's going to lose a few cycles or something.
Especially when you're running a big robot like a lawnmower.
Yeah. So,
dude, a pirouetting lawnmower? Get out of here. I need video of that.
Yeah, exactly. I want to see the little cuts in the grass and spirals. Like what was that? Spirograph? Remember Spirograph?
Yeah,
those are awesome.
I love those things. I 3D printed one. One of the first things I printed on my printer was some spirography sorts of things so I could live childhood and things with those things.
Yeah.
I just put a thing in the chat that's got a link to that fella that's got his robot online, and there's currently 20 some odd people there watching it, and you get to control it. Throwing it to a pound, it gives you instructions in the Twitch channel when you log in and see it to say what you can tell the robot to do. And I'm like, that's what this whole channel is. I'm wondering, okay, cool. I got out and it actually works. I played around with it a little bit, but it, burns out after a little bit. But what the hell? It's don't charge all the time, so it turns out it's used. But I'm like, okay, that's what people do.
See, that's cute. We had there's a Tom, one of the club members, had wanted to do this a couple years ago. He talked about pulling one of these together and putting it online. Nothing ever became of it, but that's pretty cool.
Yeah. Some JavaScript and a few other things to watch the chat,
But the Yankee Bot is it's no longer made, right? That fell apart, didn't it?
I have no idea.
Yeah, I think so. I think that was a Carnegie Mellon spinoff, and it went well gangbusters for a while. I could swear it fell apart as a company.
I remember hearing about this online garden once where it was this robot arm and you could plant seeds and people would log on and water the garden and take care of it and stuff. It was shut down. I don't know why, but it was kind of cool.
I get the feeling there might be a real chance for overwatering in a garden like that.
Yeah, I think there was a lot of regulations though. Like you had to pay for some of it and stuff like that.
I just got a quick note for Chris. I was playing around with my video capture code, and it turns out I actually was creating the camera for every single image. And I've got to figure out, there's a with statement in Python that closes the camera every time, and so I've busted my code. But the first time I tried to run it, it spun stuff past the screen so fast I couldn't even see it. So yeah, there's something in my code wrong. The camera can go at video speeds. So yeah, so I've got some work to do.
You'll get there.
Yep.
Okay, we'll see you, Jack.
There we
Jack
go. I couldn't hear everything you said.
Oh, I was just going to mention that there's a with statement. It's sort of like a try with resources in Java. But basically, if you use the with statement to get the camera, which is how they recommend doing it, it'll automatically close the camera and the stream after the image is taken. And it turns out that I was doing that every single image, which is why it was taking so long. And so I found some example code and tried it. I've now broke my code, but the first time I ran it, it ran like at video speeds. I was seeing my console was just spinning images past as fast as it could spit it. So I think there was something simply wrong with my code. It should run it. In fact, there's even an example of how to pull fixed images, JPEGs, out of the video stream. So I'm sure I can speed it up.
Yeah, that's probably a using statement, so that whatever method of Python's disposal it's probably disposing that thing as soon as it goes out of scope, to maintain memory and spooling it back up again. Yeah.
It's just a bug in my code. Basically, I was using an example of how to use the camera to get one image, and I was just repeating that over and over again. And in reality, there's a number of ways to get multiple images out of the camera fast, and I wasn't doing it properly, so it was just my fault.
Oh, and the other thing in my life, I had an alternator go out, I believe, on my Pontiac Montana, which turns out to be the most unrepairable car ever made. It was a space consideration. So any of you guys want to just run over here next Saturday and, want to wrench on a car? I mean, I'm taking volunteers is what I'm saying.
Harold, I'd come, except it's a long flight.
Yeah, I know it's a long trip here, Murray, but I know you'd be here, though. I know, Murray, you want to be here. I got it.
I love working on cars.
The thing is, I don't know many people that can wrenches on cars a lot, so I can't whine to them. And the one person I do lives right up the street from me. His name's Willie. He's my mechanic. Well, I say he was my mechanic, because due to all the COVID and the shutdown and stuff, and he didn't want to go through all the regulations and stuff, and he's nearing. I don't know how old he is, but his wife I know is 65. So they're just kind of tired of all this mess and having to imagine getting gloved up and masked up and disinfecting everything you do to go get greasy working on a car underneath wherever it is, everywhere you go. in the heat, and he goes, man, I'm just not doing that. I want to sell everything and do the thing. So I want to go whine to him about this because I know he will understand. But I don't want it to appear that, hey, I'm whining to you, hoping you will offer to come help me, because that's not what I want, because this is not what you do anymore. I want you to wrench on your stuff, which is he's like us. I say he's like us. Yes, he works on cars for a living, but that's also his hobby as well. And I want him to do his hobby. I don't want him to come down to my place and help me, because I can get it done. It's going to take me a little longer than it take him, but just to give you an idea, one of the recommended ways to change this alternator: jack up the car on the passenger side, remove the passenger wheel, okay, the passenger side wheel, unbolt the top two motor mounts, then go underneath and put a jack under what's still holding up the engine and unbolt those and drop the engine about 6 inches. And then you can get to work on the alternator. I'm like, no, I got to do something different than that.
Well, Harold, if I might have a suggestion.
This.
Harold, you've gone to this trouble of explaining all this to us. So what I would suggest is just pointing him to the YouTube video we're creating right now, and he'll get the full explanation.
Yeah, Harold.
I could do that. He's actually pretty handy in a lot of things. He doesn't. It was funny, is over the years he's asked me a bunch of computer questions about replacing parts and doing all the other things that you might imagine. And I said, well, have you looked? He goes, well, I found this place out of Australia that'll sell me one of these drives, and it's a direct fit and this kind of thing. But I was wondering if it's like, no, if you've looked and found it, you've done exactly what I would have done. You've already got this, and he's really good at what he's got all the stuff. He just doesn't think he can deal with the software portion of it. He doesn't he doesn't feel very confident with dealing with that. But he's not having to do that. He's replacing parts in a computer and laptops, and because he's handy with tools and all those other sorts of things you might imagine. Yeah, he's a good guy too.
An international Harvester Scout that it was kind of tall fenders on it, and to do anything on the engine, I could actually put my feet in the engine compartment and sit on the fender, and it was very convenient. So everything was very accessible.
Very accessible, yeah.
So.
Apparently, this isn't the only car that does it, but there's several of them in this class. Back in 2003, somewhere in 99 to 2006, there's a half a dozen cars built essentially off the same chassis and engine compartment size and same engine and all that, and they all have the same problem. I just literally, there's a 1/4 inch to get out a 6 inch, a 3.5, 4 inch bolt out of the alternator to get it off. The way they've got it designed, I got a way around it. It's going to take lots of extra removal of stuff that I got time. I got the tools. It'll be all right. It'll be a good Saturday morning.
There you go.
Yeah.
All righty. Hey, let's see. So I think there's 3 folk we haven't heard from yet. Just randomly picking Mr. Ackley. Any news in the last week? How are things at your end? No excitement. Oh, audio not working.
Yeah, you're on mute, Dave.
There you go.
About the only thing which Doug can relate to, I got my 30 amp circuit wired in now.
Oh.
30 amp circuit.
Inside joke, right?
Very good. So either that there won't be anything that smokes, or something that smokes will smoke really fast.
Well, actually, what I did was I found that our stovetop is got a 30 amp breaker on it, 220. But ours is gas. So there was the breakers already there for me.
Makes it easy. Good job. All right. Okay, let's see, Mr. John, how about you?
Well, the only thing I did was scout for a bike over at Grapevine. So if you have any info on bike or kayaking over there, I'm all yours. So that was my
Huh.
thrill for the weekend.
You mean places to bike or?
Yeah, places to bike, because there's a trail over there like 15 miles on the north end of the lake. It was like.
I've heard it's a nice mountain bike trail, but back when my daughters were in high school, one of the kids from the band was out with his dad. They were doing mountain bikes on the Grapevine Lake Trail, and the son got bit by a rattlesnake.
Yeah, I can see that.
He had to ride after the snake bite. He had to ride his bike back, and then they took him and got it bled out or whatever. But then because he's in marching band and they're kind of merciless, so he had to go do marching band just a day or two later, and he's hobbling around on this massively swollen leg. But
because there was a lot of trees and it wasn't too clear.
Yeah,
for the path.
Yeah, we
So I was like,
we did a little bit of mountain biking on that trail. I remember one day there was a guy. He was like using rocks to bend out a tacoed front wheel, and he had like dried blood and dirt all over his face, and apparently he nosedived in and tacoed his front wheel. And
so you're telling me I might be better off on kayaking instead of biking over there. Of course, over there you realize you have the big boats.
Going crazy in the front, but he was on it and it was holding air. But he looked like
he didn't bleed out, so he made it back.
Yep.
All right.
But,
so, Mr. Kareem, how about you? You got the man of mystery still photo going on. Any video? Any exciting robot stuff in the last week?
No, I got nothing new. Not since the last thing I shared.
Oh, that was pretty cool. That was good for at least 2 weeks.
Yeah.
I'll take that.
You should. Yeah, well earned. All right, so we got cat video at Harold's place in the lab. Doug P, did you had something you showed earlier? Was that it, or do you have more to show? With the mute button hiding somewhere.
I didn't have anything more to show.
Oh, Doug D and Doug P and Dave A and Dave A. This is all just overloaded.
Okay.
Yeah.
Well, I have an old something that I've been looking at for a long time. This is a HP plotter, an HP 7475 that I salvaged out of the Makerspace giveaway.
Awesome.
Show. But the big problem was to make it work. Well, I found an Instructable that showed you how to hook the serial port out from the actual chip. So I have 4 wires now. Let's see if I can show you the 4 wires. See the 4 wires?
Up a little higher.
4 wires.
Yep.
Those are plug into a USB to TTL serial converter. And dang if it doesn't work. Just pulls right out. And what I really would like to do with it is make some sort of vinyl cutter. But I don't, I've read a few YouTube stuff and where people have hacked it to make it, and it looks like a lot of work. But I'm thinking that maybe a small laser module, maybe a 2-watt laser module or something, and using that to be a vinyl color. Vinyl emits vinyl chloride, which will screw up the lens on most things. But these little 2-watt laser LED lasers are so cheap, it might not, and as much as I would use it, probably be something I could figure out a way to do. So anyway, kind of cool.
It's a cool project.
Yeah.
All right. Let's see. I think. Have we made it all the way around the table in record time tonight?
Yep, did pretty good. I can show you pictures of my vacation if you want to see it. I don't know if you want to record it, but my wife and I went up to Oklahoma.
You should advise us. I mean, I just can't imagine with the videos. Should it be recorded or should I turn the recording off?
It's pretty much, PG rated, I think.
Okay.
PG.
Nothing too, obscure. So if you want to see it, if you don't, that's fine.
It sounds like we're done on robot-y stuff. So if anyone wants to bail off or hang around and watch vacation photos, and this could be just a laid-back evening here, that'd be fine with me.
Yeah.
Well, I've got to go back to work, unfortunately. So.
Oh man, what a drag! Good to see you.
I've got a few more hours in my day. So, all right.
Yeah.
See all you
All
guys,
right.
and thanks for everything. We'll see you next week.
Good afternoon.
Before
Catch
he
you later.
leaves, though, anyway, regards to Saturday, when are we doing it?
Oh, Saturday. I have to send out the meeting invite. Chris is going to send me a bit about his simulation thing, and I need to confirm with Ron Grant. But it'll be, I assume we'll just do the 1 o'clock time in case, to make it easy for New Zealand.
Sounds
easier.
good.
Okay.
But okay, so that's cool. So I'm going to hit the stop recording, and then